Hello everyone, and welcome to the Nested Statements and Scope lecture. So we've gone over writing our own functions using lambda expressions, etc., but now it's important to understand how Python deals with the variable names we actually assign. Before we start this lecture, what I want you to do is read and code through the entire Jupyter notebook for this lecture. This is a super important topic for fully understanding the more advanced Python programming features. So what I want you to do is read through the entire Python Jupyter notebook, read through all the code, code it out yourself, make sure you understand it, and then come back and we're going to explain those ideas further. Okay, so let's go ahead and get started. Through a quick introduction, so like I mentioned before, we've written our own functions. Now let's understand how Python deals with the variable names we assign. So when you create a variable name in Python, that name is stored in what's called a namespace. And variable names also have what's known as a scope. And the scope determines the visibility of that variable name to other parts of your code. So let's see a quick example of this. Here, we have the cell block that was in the Jupyter notebook. So as I mentioned before, you should have gone through the Jupyter notebook already and typed out this code yourself. So we have the cell block, we have x equals 25, and then we have this function printer, which sets x equals to 50 and then returns x. So what do you imagine the output of printer is, and what do you imagine is the output of print x? So the output of that print x statement is 25, and the output of print printer is 50. So if you notice here, you basically have two different x's, one for printer and one in a more global scale or scope, which we'll learn about in a second. So what we really want to figure out is, how does Python know what x to refer to in your code? And this is where scope comes in. So Python has a set of rules it follows to decide what variables, in this case x, you're referencing in your code. And what we're going to do is break down some of those rules. Okay, so this is what I just said. Let's go ahead and break it down through name assignment. So name assignments will create or change local names by default. And name references search at most only 4 scopes. The 4 scopes are local, enclosing functions, global, and built-in. So let's go ahead and start with a quick definition of all these scopes. First, local scopes. So names assigned in any way within a function, such as a def function or a lambda expression, and not declared global in that function. That has a local scope. So if we go back real quick, that x equals 50, it's defined within a function, printer. So currently that has a local scope, which is why when you call printer, it returns 50. Okay. Next, if it couldn't find it in local, it looks for enclosing function locals. So the name in the local scope of any and all enclosing functions, such as def or lambda, from inner to outer. And we'll see an example of that in a further slide. After that, it checks for global. And those are names assigned at the top level of the module file or declared global in a def within a file. And we'll talk about the global statement in just a second. After that, it checks for built-in names in Python. Those are names that are pre-assigned built-in names in the Python language, so such as open, range, syntax error, etc. So let's go ahead and break down a few examples of all 4 of these. So first with local. So for instance, if you have an expression here, x is local to that lambda expression, or any function. Next, enclosing function locals. This one's a little different. So here I have an example which you've already coded through. I'm assigning name is equal to this is a global name outside of any function. Then I create a function called greet and name equals Sammy. And then, this is something a little new that we haven't seen yet, I put a function within that function, I enclose it, and I have a function called hello, and it prints hello plus name. Then I call hello in my greet function, and then at the end I call greet. So if you notice, it prints hello Sammy. So what happens here is, if we work inside out, we have this hello call, and if we look at the function hello, it says def hello print hello name. So what Python's going to do is it first looks for a local scope. Is name defined anywhere within this hello function? It's not. Okay, then let's go to enclosing functions. Is hello enclosed within another function? It is. It's enclosed within this greet function. It looks for the name variable there, and here it is, name equals Sammy. So now that it's found it, it brings it back here. It won't actually go all the way out to this global because it's found it already in the enclosing function. All right. Next up, global. So globally, if I were to just say print name, since I defined it earlier here with outside of any function, this is a global name, it'll print this is a global name. And then built in, we've seen a ton of examples of these, such as len, which is the function length, etc. So you want to be careful not to overwrite any built-in names. All right, so moving along, local variables. When you declare variables inside a function, they're not related in any way to other variables with the same names used outside the function. So variable names are local to the function. And this is called the scope of the variable. And all variables have the scope of the block they are declared and starting from the point of definition of the name. So we kind of just went over this, but let's go ahead and break it down a little further. So here's one more example. I've assigned here x is equal to 50. This is a global variable. It's global in scope. Then I have a function, func, which takes in x. It prints x is x, resets x equal to 2, prints changed local x to x. Then we're going to call that function and print x is still. So what happens here? I say x is 50. So that's this line right here, print x is. So the function takes in 50, it says x is 50. Locally, it changes x equal to 2. It does not change the global variable, which then it says changed local x to 2. But outside the function, even after we call the function, if I were to print x, it still stays 50. So it only affects that change on a local level. Now what if we wanted to change that on a global level? So if you want to assign a value to a name defined at the top level of the program, not inside any kind of scope such as functions or classes, which we'll learn about later, then you have to tell Python that the name is not local but it's global. And we do this using the global statement. So let's see what that looks like. So here, it's the same code you've gone through before in the Jupyter notebook. I have assigned x is equal to 50. And now, this is where it gets interesting. Within my function here, I say global x. And this basically tells the function, hey, I'm looking for the global name of x here. Whatever changes I do will affect x globally. So then I print, this function is now using the global x. Print, because of the global x, is print out x, resets x equal to 2, print ran func change global x to x. So outside of the function, what I first do is I print before calling func x is, so let's see the output. Before calling that function, x is 50. Then we call the function, and this function is now using that global x. Because it's global, it knows x is 50. It resets the global x to 2, and then even after calling the function outside of the function, x is now equal to 2. So with that global statement, I can affect name changes to variables that have a global scope using that global statement. And I'll use that a lot throughout the project of the blackjack game that you'll see later on in this course to really nail it in that global statements allow us to take in global variables. Okay, so in conclusion, one last thing I want to mention is that you can use globals, a built-in function, parentheses, and locals, another built-in function, to check what your current local and global variables are. And another thing to keep in mind is that everything in Python is an object. So I can assign variables to functions just like I can with numbers or any other type of objects we learned about in the first section of this course. So we're going to go over again this whole idea of everything in Python as an object a lot more in the decorator section of this course. But I just want to mention to you now so you have a feeling of what to expect. Okay, so let's hop over to the Jupyter notebook really quickly. So again, you should have gone over this entire notebook before seeing that slide presentations, and go over this code and make sure you really understand what's happening here. So the things that are important to understand, it's important to understand for this cell block why x is printed as 25 here with this command, and why it's printed as 50 here with this command. That's crucial for your understanding of how variables and nested statements and scope works in Python. Once you have a good feeling of why that's happening, you need to make sure you have a good feeling of why this is happening. Why is hello Sammy being printed instead of hello, this is a global name? Make sure you understand that, and then finally, make sure you understand these last two examples. This one right here, why x equals 2 is printed only when you call that function, and then x is still 50 globally. And then you also need to understand, after reading all this example here, why x is 50, and why, since we called global, x is equal to 2 resets the global x to 2, even outside of the function. Okay, once you understand those examples, you pretty much have a full understanding of scope in Python, and you're ready to go. So take your time with this lecture. This should take you about a whole day if necessary to really understand what's going on, but make sure you take your time to really understand nested statements and scope. Okay, thanks everyone, and I'll see you at the next lecture.